same exact material.
Really?
Uh-huh. It's kind of interesting. I don't know that I've ever had a day like that. So they want a 2-column proof for all of these.
Mm-hmm.
All right, so let's start a 2-column proof. Most people consider proofs the hardest part of geometry.
I would agree.
Yep, that's what every student has said today. Well, proving congruency of triangles is actually one of the easier things to do.
Mm-hmm.
Why? Because there's only SSS, SAS, AAS, and ASA. That's the only way, that's the only 4 theorems that govern non-right triangles. There's always also HL for right triangles. But all of these problems here tonight are non-right triangles. So they have to fit one of those 4 things. And that's important to remember. And remember that AAA is not proof of congruency.
Gotcha.
Okay. So, the first one. What is statement 1?
Line segment AE is congruent to line segment AH.
And
the triangle,
the angle.
my bad, sorry. Angle YAE is congruent to angle YAH.
And that's always the first thing in a 2-column proof. Is you start with the given. Okay? And then you look to what we're trying to prove. We're trying to prove that this triangle is congruent to that triangle.
Mm-hmm.
Okay? So remember, this is what we have to work with. And only that. How much information do we have so far?
We know that 2 angles are congruent and 2 segments are congruent.
Okay. So that eliminates the side, side, side. It could be one of these 3. What else do we know about this figure for statement 2? In other words, we know that this side, AH, is equal to that side, AE. And we know that that angle is equal to that angle. You always need 3 pieces of information to prove congruency. We have 2. Where can we get a 3rd?
I do not know.
I'm sorry, what?
Oh, I said I don't know.
Well, which side, in other words, this triangle and this triangle, we need either another angle to be equal or another side to be equal.
What about this segment YA?
Yeah.
Because it bisects too.
It's not because it bisects, it's because it's equal to itself.
Gotcha.
And that's, I've been looking at these all day long, and that's common to almost every single problem, is the ability to recognize a side that is, or an angle, that is common to both triangles.
Gotcha.
What's the property that says YA is equal to YA?
Property of reflection?
Yeah, very good. That's one of the harder ones to remember. I'm sure that's why they're giving it to you. That's the reflexive property. It's the most annoying one.
Mm-hmm.
Because why should you have to prove that YA is equal to YA? But you do. Okay?
Right.
And now we have an equal side, an equal angle, and an equal side. Can we fit it into one of those categories?
Yes, the side angle side.
Yeah, so statement 3 is triangle YAE is equal to triangle YHA because of side angle side. Now, you may know this already, but I'm going to go through it again because this is the biggest problem that most of my students have is figuring out the order that you put those. Okay? Well, we know that side. First of all, we don't know anything about YH, right?
Right.
So if we're going counterclockwise, the first thing we run into is side HA, AH.
Mm-hmm.
We know that's congruent to AE, this side over here. Okay? So the key to all of these problems is to maintain a consistent orientation, meaning either go clockwise or counterclockwise. You'll end up with the same answer. But notice that if we go counterclockwise, we have side, angle, side. If we go clockwise, we have side, angle, side. So it doesn't matter which direction you go in. What's important is you start with the end point. In other words, we don't know about YH. Okay? So if we're circling this triangle, this one right here, and we're circling for some piece of information that we know, well, we know that AH is equal to AE. And don't even picture that triangle. Eliminate that from the picture. Okay? Because all we know is that that side is equal to some side in this triangle. And then we're going counterclockwise, like this. Next thing we run into is this angle. That angle is equal to this angle from this statement right here. Okay? So we have side, angle, and we figured out that that line segment was equal to itself, and that is common to both triangles. So you have side, angle, side.
Sure.
Okay? And the important thing to remember when you're figuring out the order of these letters is to go in the same direction the whole time. You can go in either direction. In other words, I could go clockwise if I wanted. But if I'm going clockwise, I don't know that. I don't know that angle there. But I know that side is equal, and I know that angle is equal, and I know that side is equal. So even if I go clockwise, I get side, angle, side.
Gotcha.
The thing to do is to never reverse order. In other words, I've had a student today tell me this was side, side, angle. Well, the only way you can get side, side, angle is to go side, skip that angle, this side, and then go in the opposite direction to get that angle.
Gotcha.
And that's the way you would get side, side, angle. And this is not side, side, angle. And in fact, side, side, angle does not prove congruency. Just introduce you to a little bit of trig, because this will be important in trig. If I gave you side, and notice that when I define this, I'm going to start from there, and I'm going to go counterclockwise. So this would be side, side, angle. Okay? I could start from there, in which case it's angle side side. Same thing. Reversing the order of the letters does not matter. Okay? In other words, this is side side angle or angle side side. It's not side angle side. Well, that looks like it would prove congruency, because there's the congruent triangle, but notice that there is another triangle that can be drawn from those dimensions. And that's that one right there.
Gotcha.
Which means that side-side angle does not prove congruency. Remember, congruency, that thing has to equal that thing. Has to have the same three angles, the same three sides. Clearly, they do not.
Gotcha.
So that's why side-side angle does not prove congruency. You have to have, if you have two sides, you either have to have that or you have to have that. That's it. In other words, if you have two sides, you have to have one of those two situations. If you have two angles, it can be that one or it can be this one. Those four are what you look for.
Gotcha.
Okay. In this case, we have side, angle, side, going counterclockwise or clockwise. Oops, hold on. I'm trying to get this right. I'm going to have to use my mouse. Start right there. First statement is what?
That the segment YI is parallel to segment SE.
And that's always the first statement, is what they give you. What else did they give you? That's also part of the first statement.
That case, the midpoint of segment YS.
Okay. So, they want us to show that this triangle is congruent to that triangle. Okay. Remember, I either need side, angle, side. I need side, side, side. I need angle, side, angle. Or I need angle, side, side. Let's take the first thing they give us. YI is parallel to ES. What does that mean in terms of angles of these triangles?
Well, they're never going to intersect. So
if I have two parallel lines, which angles are equal?
Um, 1 and 4, 3 and 2, 5 and 8, 7 and 6.
What else?
7 and 3. 1 and 5.
In our picture here, which two angles are equal?
Y and S.
Correct. 3 and 6. Or 5 and 4. By which theorem are they equal?
I don't know.
You got four theorems. You got alternate interior. You got alternate exterior. You got corresponding angles. And you got adjacent angles. So you've already figured out that angle Y is congruent to angle S. And I don't need a separate statement. I'm going to just put in there also that angle E is congruent to angle I, right?
Right.
based on the fact that that's parallel to that, that's alternate interior angles, that's alternate interior angles. We have two transversals here. Okay? So, what's the reason?
Adjacent angles?
Not adjacent. Alternate
Exterior.
interior
Oh, my bad, interior.
of parallel lines. Now hold on. Before we go any further, I want to make sure you understand why it's interior instead of exterior. Interior is anything in between the parallel lines. Alternate means on the other side of the transversal. So 3 and 6 are alternate interior angles.
Gotcha.
So are 4 and 5. Tell me two alternate exterior angles.
1 and 8.
Correct. Or
7 and 2.
okay. What are corresponding angles?
1 and 2.
No.
1 and 4.
5.
Oh.
Notice why they're corresponding. And they are equal. What else is corresponding?
2 and 6.
What else?
7 and 3.
You got it. Okay. And the only other thing is adjacent. Adjacent angles are what?
5 and 6.
Okay, what else? Go up and down.
1 and 3.
Okay, but those are also linear pairs. In other words, 5 and 6 and 1 and 3 are linear pairs. They're always supplementary. Which two angles are adjacent with regards to parallel lines?
Like 2 and 8?
No. Adjacent. They have to be next to one another.
Okay, so like 4 and 6.
The theorem is that adjacent angles are always supplementary, meaning they add to 180.
Okay.
What other angles are adjacent?
4 and 6.
Yep. What else? Basically everything. 7 and 8 are adjacent. 5 and 6 are adjacent. 5 and 7 are adjacent. 6 and 8 are adjacent. 3 and 5 are adjacent. 4 and 6 are adjacent. 4 and 2, 3 and 4, 1 and 2. In other words, any two angles that are next to one another.
Gotcha.
And they're always supplementary, meaning they always add to 180 when you have parallel lines. So, if we go back to our proof, that's why angle Y is equal to S and angle E is equal to I, is because they're alternate interior of parallel lines. That's probably all you need to say. In other words, I don't know that you need to quote the exact theorem. The most important part of geometry is to know what parallel lines means.
Right.
It's not to know the exact theorem. In other words, I don't really care whether you remember its alternate interior. You know what I mean? The important part is that you know that when you have a transversal, that angle is equal to that angle. Or that angle is equal to that angle. If you don't know that they're alternate interior, it doesn't matter. When you take all your tests, your ACT test, your SAT test, any math test that you're ever going to take, is all you need to know is that they're the same.
Gotcha.
You don't need to know this. For geometry class, you need to know that.
Gotcha.
All right. Now, let's see, what else? So at this point, notice that we're trying to prove that this triangle is congruent to that triangle. Whenever you're trying to prove congruency, you need three things. How many do we have now?
3.
We only have two.
Oh, right, because K is the midpoint.
We have two angles. What's the third letter have to be? S or A?
S.
Correct, because A doesn't prove congruency. Angle, angle, angle proves similarity. In other words, if that's the same as that, and that is the same as this, and the third angle is always the same if the first two are the same, that proves similarity but not congruency. So A doesn't prove anything for congruency, which means since we have two angles that we've proven are the same, the third thing that we're looking for has to be a side. You see why? In other words, so now we're looking at this figure and we're trying to figure out, so what side is equal to the other side in the triangle?
Would be like S and I and E and Y?
Well, first of all, SI is not a line segment. There's no line between those.
Okay, gotcha.
So we need one of the lines in those triangles right there to be the same as one of the lines in this triangle. Well, go back to the given. Read the given. Which two line segments are the same?
YI and SE?
No. In other words, we know those two lines are parallel, but nobody has told us, there's no indication that they're equal. ES and YI, we don't know they're equal yet. They look equal. We could guess that they're equal, but you don't want to do that. You have to find proof. That's the whole point of a proof, a two-column proof. Is you have to prove that YI is equal to ES. Well, we can't do that. But look at this statement right here. K is the midpoint of YS. What does that mean?
That YK equals SK?
You got it. Line segment YK has to be equal, or congruent, excuse me, to KS. Why?
Because of angle sine? No.
Definition of midpoint. In other words, if K is the midpoint of YS, by definition, YK is equal to KS. In other words, midpoint means, same thing as bisector, it means you're taking a line and splitting it into two equal parts. Or you're taking an angle. If I have an angle and I have a line that bisects that angle, then that angle is equal to that angle. So the definition of midpoint or bisector means that YK is equal to KS. All right, now look at what we have. We have two angles that are equal. We have one line that's equal. That's the three pieces of information we need. Angle, angle, so we got some combination of angle, angle, side. We know it has to be angle, angle, side. Can't be angle, 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 because that doesn't prove congruency. So we see that we have two angles that are equal. Well, the third thing we're looking for has to be a side. Notice that this angle is equal to that angle. That doesn't help us. Because all that tells us is that we have three equal angles. But if I know that YK is equal to KS, that's the side. So now I know we have two equal angles and one equal side. Now, the toughest part is to figure out what the order is. What is it?
SKE?
Give me either AAS, ASA, or SAA. In other words, we know we have two angles and one side. So it has to be some combination of those three letters.
So like...
Okay, what's the first thing you know about the bottom triangle? Do you know the length of KE?
No.
Okay, do you know the angle E?
Yes.
Okay, let's start there. Now we want to either work counterclockwise or clockwise. And that's all you have to remember, is that wherever you start, work counterclockwise or clockwise and don't reverse the order. So we know this side, or excuse me, we know that angle E. We don't know ES, but we know angle S. So we have angle, angle, side, working counterclockwise. So I can state that triangle EKS is congruent to triangle YKI because we have angle, angle, side. Now notice, I didn't have to start with angle E. I also knew that angle S was equal to angle Y. Excuse me. If I go clockwise to the last piece of counterclockwise to the last piece of information I have, I know that line segment is equal to that line segment. Okay? So let's start there. Well, that's the side. And instead of going counterclockwise, because we really don't know anything about this angle here, well, bear with me here for a second. If I start with that line segment and I go counterclockwise, I get SAA. That's the same as AAS. Whatever order you get with your three letters, the reverse is always the same. Always proves congruency. If I take SAS and reverse it, I get SAS. If I take AAS and reverse it, I get SAA. Both of those prove congruency. And if I take ASA and reverse it, I get ASA. So reversing the order does not matter. The important thing is to never reverse order in the middle. In other words, I had a student today who told me this answer was ASA. Okay. Well, notice, in order to get ASA, I would have to go angle, skip that angle, go to that side, and then go backwards. In other words, I'm going counterclockwise, and in the middle of it, I got to go clockwise. That's never correct.
Gotcha.
Whatever direction you start, go until you get all three letters. And it doesn't matter which way. You can start with this side right there, and you get side, angle, angle, as long as you go clockwise. And that is the same as angle, angle, side. So, and that seems to be the major area that students are having problems with. I mean, I've done this 4 times today, and the other 3 students, the only problem they really had was figuring out what order to put the letters. And it all has to do with either going clockwise or counterclockwise and maintaining the direction.
Gotcha.
All right. Let's look at 3. Each one of these gets marginally harder. The first step is always given. What's given here?
That the segment AG bisects angle A, and the segment GA bisects the angle G.
Now here we have an angle being bisected, not a line. But it means exactly the same thing. It means splitting up this angle A into 2 equal parts. So what's the very first thing we can say, given the information they've given us? Now we're trying to prove that 2 line segments are the same, but the way to prove that the best is going to be to prove that this triangle is congruent with that triangle. Once I prove this triangle is congruent with that triangle, then BG will be equal to NG.
Gotcha.
Okay. Well, what do the given mean? Which angles are equal? Whenever you're trying to prove triangles are congruent, you have to prove angles are equal and sides are equal. And then as soon as you get 3 pieces of information, that's usually enough.
Gotcha.
So when AG bisects angle A, what does that mean?
That means that angle BA has to be the same as AM.
Not BA, but BAG. Remember, you have to define angles with 3 letters or 1 letter. It's okay if I define that angle as angle B. I cannot define that angle as angle A. It's not angle A. So I need 3 letters, the middle of which is the vertex of the angle. So it's either BAG or GAB.
Okay.
What is it congruent to?
Angle NAG.
And also, GA, that line, bisects this angle down here. So what other statement can I make?
That BGA is congruent to NGA.
Okay. Now notice that I have 2 angles that are congruent. So my final answer has to be consisted of what 3 letters? There's the 2 angles. What's the 3rd letter got to be?
The side.
Yes. Can't be the angle. Because angle, angle, angle does not prove congruency.
Okay.
So it's got to be an S. Okay. So now we're searching for a side that's equal.
Would it be AG is equal to itself?
Line segment AG is equal to itself based on what principle?
property or reflection property?
You
Reflective property.
reflection. That's a good reflexive property. That's a good one to memorize because all the problems I've seen so far involve this. In other words, you got transitive, you got symmetric, you got substitution. If you want to memorize any one, remember the reflexive.
What would be the number 2? What would that reasoning be?
Oh, definition of bisects.
Gotcha.
In other words, angle BAG is equal to that because they told us that it bisects it. That's not a theorem. I don't think it's a theorem. I might be wrong there. But it's the definition of bisect. Okay? If you bisect a line, you divide it into 2 equal parts. If you bisect an angle, you divide it into 2 equal angles.
Gotcha.
So when they say that AG bisects angle A, that means that angle is equal to that angle. When they say AG bisects angle G, then that angle is equal to that angle.
Gotcha.
So that's the definition of bisect. Now, notice, what do we have? What are we looking for? We're looking to prove congruency of the triangles. What information do we have? Remember, we always need 3 pieces of information.
We have angle, side.
Okay. Now all we have to do is put it in the right order. So we have angle, side. Let's look at the picture again. We know that angle is equal to that angle. We know that angle is equal to that angle. And we know that side is equal to itself. So do we have angle, side, angle, or angle, side?
Angle, side, angle.
You got it. In other words, as long as you go in the same direction, you're never going to get it wrong. So triangle ABG is congruent to triangle ANG because of angle, side, angle. Now that we've proved congruency, why is BG congruent, to NG? This is a tough one to remember. 5 letters. Starts with C. C, P, what's the rest of it?
I don't know.
CTC. What does that mean? It means corresponding parts of congruent triangles are congruent. Notice that BG is the corresponding part to NG of these 2 triangles. And we didn't have really any information to prove that BG was equal to NG until we proved that this triangle was congruent with this triangle. Once we prove that, then AB is equal to AN, BG is equal to NG, all 3 angles are equal to these 3 angles. In other words, once you prove congruency, then all of the corresponding sides and angles are congruent. So that's the reason I'm going to give for why BG is equal or congruent to NG is CPCTC. And you use that a lot, so memorize that. But it means corresponding parts of congruent triangles are congruent. So these 2 C's mean congruent. This first C means corresponding. Number 4. It's clear to me that you know what the first thing is always. It's whatever they give you. I mean, that's the easy part of proofs.
Right.
All right. So let's see what they've given us here. Again, they want us to prove that an angle is equal. Well, most likely when they want us to prove that, we have to prove that two triangles are congruent. In other words, the very last step is going to be S is equal to N because corresponding parts of congruent triangles are congruent. What are my two congruent triangles? SWI and WHN. If I can prove that those two triangles are congruent, then I'll know that angle S is congruent to angle N.
Gotcha.
Okay? So, what do we have to work with? What have they given us?
That segment SW is congruent to segment NW,
Okay.
and that segment IW is congruent to HW.
Okay. So that's given. That's two sides, right?
Right.
What's the third letter have to be?
Oh, my bad.
It could
Angle.
be S, but if it's not S, it's got to be A, and it's got to be in between the S's.
Can you have it where it's SSS?
You can have SSS, yes, that proves congruency.
Okay.
But the one that does not is SSA. That does not prove congruency. So if you find yourself having two sides, it's got to be one of these two. Well, we've got this side, we got this side. Do they give us any information that tells us that IS is equal to HN? They do not. So we can cross that one off. So that's the only thing we have to work with to prove congruency. Well, we know this side and we know that side. Which angle must be equal?
Angle W.
And why?
I don't know.
What's the property that applies to line segments? It applies to angles. It applies to
bisector?
reflexive.
Oh, sorry.
Reflexive is the one that says something is equal to itself. It doesn't really matter whether it's a line segment or an angle. Angle L is equal to angle L. Why do we have to state that as a statement? Because we have to have three things. In other words, in order for us to prove that triangle is congruent with that triangle, we need three properties. We need at least three things. You can't always do it with three things. In other words, angle, angle, angle doesn't work. But three things are the minimum that you need. We see that we have two sides that are congruent and an angle.
So side angle.
So the next thing I'm able to write is that this triangle is congruent with that triangle. SWI is congruent with triangle SHN. WHN. Why? You might have just said, but say it again.
I don't know what I said.
All right. This is where everybody has the problem.
Is a side angle angle?
Yes. No.
Okay. No.
We have two sides and one
Oh,
angle.
no, that's side angle.
Nope. That doesn't prove congruency.
Oh.
What's the only thing that proves congruency when you have two sides and an angle?
Um.
Side,
Oh,
angle,
SAS.
side. Now, let's figure out why we have side, angle, side. Let's take this triangle here. We don't know anything about IS, right?
Right.
We don't know anything about angle S. If I'm working my way clockwise around this triangle, the first thing I know is that SW is equal to WN. Okay, so let's go with that. And the most important thing to remember is don't reverse directions. If I'm going to go clockwise, go clockwise. Well, I got that side that's congruent, I got that angle that's congruent, and I got that side that's congruent. You don't even need to look at the other triangle. It's not important. Once you've determined that you have two sides and an angle, the only thing that matters is the order you write those letters. So I can eliminate this triangle from my image. And I have side, angle, side. That's why it's SAS.
Gotcha.
Now, you don't always need to go clockwise. You can go counterclockwise. It's perfectly fine. But if I'm going to go counterclockwise, okay, let's examine this only one of the triangles. You don't need to consider both of them. Just consider one of the triangles. Well, I don't know that angle, but I don't know that side. Let's keep going. Excuse me. First time I went counterclockwise. This time I'm going to go clockwise. Well, the first piece of information I know is that SW equals WN. So I'm going to start with SW. Okay? And I'm going to go clockwise this time. This time I have side, angle, side. Same thing. So when you have side, angle, side, it doesn't matter whether you go clockwise or counterclockwise. But notice that if I mixed it up in the middle, in other words, if I went side, side, angle, I've gone clockwise for the first thing, and then I reversed it and went counterclockwise, and then I reversed it and went clockwise. So don't ever reverse your clockwise or counterclockwise direction.
Okay.
Just find the first piece of information you know, go one direction or the other, and you'll get the right answer. Now, since I've proven that this triangle is congruent with this triangle, the very last thing is that angle S is congruent to angle N. Why?
Because it's SAS?
P, it's that five-letter thing.
DPCTC?
Why is that? Its corresponding parts of congruent triangles are congruent. Well, notice that in this case, the previous problem we had two lines that were the same. But in this problem, we're saying angle S is congruent to angle N because they are corresponding parts of congruent triangles. In other words, angle S is the same angle as angle N because they are the corresponding angles of these two triangles. And once you prove those two triangles are congruent, all sides are going to be congruent with their corresponding side, and all angles are going to be congruent. In other words, that angle is the same as that angle. And that angle is the same as that angle, we already proved that that angle was the same as itself. That's what made them congruent. But once you've proved congruency, all three sides are equal, all three angles are equal.
Gotcha.
All right. Now, I have one more problem that'll take just about 5 minutes, which is how much time we have left. Gotta make sure I find it. This one, yes. In other words, more problems exactly the same.
Okay.
Since we have 5 minutes, let's do one more problem. Same thing, we have to do a 2-column proof. The given Li equals Ni, Gi equals Bi, and we're trying to prove that this triangle here is congruent with this triangle here. Oops, hold on. Okay, we start with 2 line segments being congruent, right?
Right.
So what proves congruency when you have 2 S's? It's either SSS or what else?
SSA.
No, that does not prove congruency. It's got to be SAS.
Oh, yeah. Sorry.
Okay? So we either have to find an angle that's the same or a third side that's the same. Well, in this picture, the third side, we have this side, the short side of that triangle is the same, and we have the long side of the triangle is the same. So and the third side of the triangle, which is this side here, we don't have any information about. And there's really nothing there to prove that BN is equal to GL. So we probably need an angle. Which angle of those 2 triangles is going to be the same?
Angle I?
Yeah. In other words, a lot of people might say that one and that one, which is true, but those 2 are not angles of these 2 triangles. They're angles of this triangle and this triangle. So the only angle that's in common with both of these triangles is angle I. So that has to be the next statement. Why is angle I equal to angle I? What's the word?
Reflective property?
Reflection. Yeah, reflective. That's good. And memorize that, because clearly,
It's almost on every problem.
yeah, it is. It's almost on every single problem. And there's like 4 properties that are strange. This is the most annoying one of all of them, because it doesn't seem like something you need to state. But you do. Because in order to prove congruency, we need 3 things. Well, what do we have now? We have 2 sides and an angle. So, does that prove that triangle LIG is congruent to triangle NIB?
Yeah.
Why?
Um,
We have 2 sides and an angle. There's only one combination of those letters that proves congruency. It's either SSA or SAS.
SAS.
That's the only one that works. SAS. Let me just show you why. You'll learn more about this in trig, but if I have that triangle right there, notice that I have angle, side, side. If I go from the other direction, I have side, side, angle. That does not prove congruency. It certainly can be congruency. In other words, I could have that triangle that's exactly the same, but notice I could also have this triangle, which is 40, 10, 8. So having side-side angle does not prove congruency. And it doesn't matter whether it's side-side angle or reverse the letters. Neither one of those proves congruency.
Gotcha.
And it's not all, well, you'll get to more of that. It's called the ambiguous case of the law of signs, but yeah.
You mind if I ask you a weird question?
Uh-huh.
You said there was like 4 kind of weird proofs. Properties.
Uh-huh.
What are those 4 properties?
You mean the prove congruency? Oh, no, you meant the, okay. We have the reflexive. Which means A is equal to A. We have the symmetric, which means if A is equal to B, then B is equal to A. It's another silly one. By silly, I mean one that you wouldn't think you would have to prove. We have the transitive, which means if A is equal to B and B is equal to C, then A is equal to C. And finally, we have the 4th one is the substitution, which says that if A is equal to B, then A can be substituted for B in any expression. Then A can be substituted for B. In other words, if A is equal to B and B is equal to x plus 1, then A is equal to x plus 1.
Gotcha.
In other words, wherever you find an equation that has either A or B in it, you can substitute the other letter. So those are the 4 strange ones. And clearly the most important of them is the reflexive, at least according to these problems. If you take a quiz, the one you're going to have to remember the most is the reflexive.
Gotcha.
All right. Hopefully that has helped.
Definitely.
And let's end it there.
Awesome.
Connor?
Thanks so much.
Sure. And you have a good week, and I hope that helps, and I'll talk to you next time.
Sounds good. Take care.